right, and we're back for architectural decision number 3. So we're continuing the series. We're going to talk about vSAN configuration for resiliency and also day 2 operations, which are obviously very critical. So our Acme Corporation, our amazing customer, have chosen vSAN003 ESA, Express Storage Architecture, and they want to make sure... Oh, it's a fantastic decision, right? We're all for that. We want to make sure that they get all the advertised functionality. And I think the key one here is, of course, they want to tolerate hardware failures. They want to perform maintenance and be able to self-heal. So pretty reasonable requests, I would say, and typical of most customers. They also need to make sure they can do security patching in a timely manner because they want to mitigate things like ransomware, which is, of course, a huge problem in the market. So in addition to our architectural decision about the failures to tolerate setting, which, of course, we chose RAID 5, what other settings should we consider to ensure smooth day 2 operations? How interesting.
Yep.
So, requirements, James. What have we got?
All right. Well, obviously we want to be able to tolerate common hardware failures. And we talked about this before. It's 24/7 operation. So we want to be able to do maintenance without impacting the amount of failures that we can tolerate when we're doing maintenance. We want to maintain data integrity and resiliency. I mean, that's kind of assumed, I would imagine. And again, it's a 24/7 business, so we don't have outage windows. We can't take vSAN down. So everything has to operate smoothly while we're doing maintenance on at least one node. And by operating smoothly, that doesn't just mean continuing to run. It also means continuing to be protected as well.
Mm.
And on requirement 5, the applications need to perform well too. So we don't want to be in a scenario where we're recovering from a failure or where we are doing some maintenance, where doing that maintenance or recovering from that failure increases the load on the system such that the applications are experiencing degraded performance.
Mm. Absolutely. So important to ensure the solution is designed to be able to tolerate failures and maintenance operations while giving that consistent baseline of performance.
Yeah, and so had we chosen OSA, then there are some real implications in those aspects when it comes to resyncing of objects, particularly if you have a disk group failure or if you have a cache drive fail and you need to resync all of your data across disk groups. So that's something to think about very carefully if you're using OSA.
Absolutely. So obviously we've decided, not really a constraint, but we've decided to use ESA. Dedupe is not supported with ESA as we've covered, and we've chosen RAID 5. So we're going to stick with those unless there's a really good reason to change those decisions.
Yes, but we've clarified that failure to tolerate 1, when you add it with self-healing, it's actually failures to tolerate approaching 2.
Approaching 2. We should coin that phrase. Yeah. I like it.
I think we just have.
I think we did. All right. So if we are patching and we can't do it in a timely manner, then Acme Corporation could be exposed to unnecessary security threats. So this is not an insignificant risk, and I think one that a C-level executive would certainly want to be mitigated quite promptly. So
absolutely.
I think that's why it's number 1 on the list.
Yeah, and the implications of this are huge. I mean, depending on the type of business, these types of malware events can really impact the daily lives of people. I mean, I remember reading about when Maersk was hit by a malware infection a while back, and they were just extremely lucky that one of their systems happened to be offline, and so the data was not replicating to it so that they could recover from that system. I think it was in Africa. But a company like Maersk, when their systems go offline, they can't move containers. So your goods don't arrive anymore. So this is extremely important to take into consideration.
Yeah, absolutely. Or simply, data being stolen. Like if you lose people's personal information, banking details, anything confidential or sensitive data, there can be significant fines for corporations, and obviously customers leave organizations who don't protect their data. So this risk certainly should not be understated.
No.
So the next few are quite common.
So we've talked about self-healing quite a bit already, but that's extremely handy, particularly if it's difficult to get access to the data center. If you can recover from a failure event, and recover means, we're not putting in a new piece of hardware. Recover means bring your status back to being able to tolerate a failure, a subsequent failure.
Yeah, or restoring resiliency.
Yes.
As I say, it's bit my tongue. So sorry.
I was going to say well put, but actually you didn't put that very well.
No, terrible. Okay, so the assumption, because we haven't made this decision yet, this is actually in the next episode, the vSAN ready node needs to have sufficient network bandwidth to support, obviously, the virtual machine traffic, the management of the environment, vMotion, of course, which is critical to the functionality of a virtual environment, and the vSAN traffic, both front and back end. And what we mean by front end is the virtual machine's I/O that's actively happening to service applications, the back end being resynchronization activities. It could be the RAID 5 striping and subsequent balancing operations.
Yeah, and so we don't just mean here that it's going to be enough, it's going to be performant enough to support the what the applications require. That's what this back-end traffic is talking about here. So when you're doing resynchronizations, for example, if you take a node offline and you need to reprotect and reconfigure the objects so that they have that N+1 protection, that has an implication for the network traffic. So that has to be taken into consideration, not just what the applications require day to day.
Absolutely. And even, in fact, one that's not listed here is entering maintenance mode. So when we enter maintenance mode, there might be implications of how the cluster protects data during that operation. So lots of things to consider.
Yeah, that's what I was alluding to. Yeah.
Alrighty. So options. So we actually have a lot of options here. And a lot of these are probably not that well known. And I think the purpose of this episode is to make sure they are well known and well understood. So operations reserve. This is a setting which enables the cluster to reserve a small amount of space so that it can do balancing. It can do, reactive operations if and when needed. Excuse me.
Yeah. So this is moving around components of different objects such that they're balanced efficiently across the various hosts that you have in the cluster. Because, of course, different events like creating new virtual machines or putting a host into maintenance mode or adding new hosts, removing hosts, changes the relative balance of where all of the components of the objects are located on the individual disks. And so when you want to copy that stuff around, you need some extra space to do it. And that's what that's for.
Yeah.
Now, I think, now, out of these two, operations reserve is enabled by default, I think, but host build reserve, I don't think is.
I believe, and I'm happy to be wrong on this, despite what others might think. Happy to be wrong, but I believe neither are enabled by default.
Neither. Okay. So I think both are quite surprising. I don't know why you wouldn't enable host build reserve. Obviously, it reduces your capacity relative to your raw capacity. But yeah, absolutely. That's something that you're going to want to have enabled. But I'm probably jumping the gun here because we're just talking about what the options are, not what we're actually going to choose.
That's right. You're ruining the episode, James. No, I'm just joking, of course. All right. So the last couple there are maintenance mode options. So when we actually enter maintenance mode, we get a choice of how we would like to look after our data during the maintenance mode operation. One is to literally do nothing. So some data will just be not available, and the other object, which is on another node, or the stripe, which is on other nodes, will be still available, but potentially you have no resiliency at that point for some of your objects. So that's the implication of number 5. Ensure accessibility, very sensible. Obviously, we want to make sure our data is accessible, and it's exactly that. It's if any data needs to be moved in order to make sure that the data is accessible, it will do that. And number 4, just to read them completely out of order, is moving all the data off a node when maintenance occurs, and then obviously moving it back at some later date.
And this as we mentioned, is a day 2 operations decision. So this is not a set in stone decision. You're making this decision every time you put a host in maintenance mode.
Absolutely.
And what we're doing here is just creating a recommendation for which one is used. However, that may change depending on the specific scenario when you're putting your host in maintenance mode.
Absolutely. All right. So we have actually 3 sub decisions, I guess you would call them. So we've decided what, James?
That we're going to enable both of these, which I mentioned that you probably would want to on the previous slide. So enable operations reserve, meaning that we're going to reserve that those pieces of storage such that the rebalancing can occur. We are enabling host rebuild reserve, which takes a bit of storage, but because we want to always maintain our resiliency, even in the case of a host failure, we want to make sure that there is storage available in the cluster such that that n+1 can be reestablished in the event of a host failure without us having to do anything. And then finally, ensure accessibility. So we're going to recommend that the operations staff, when they are entering maintenance mode, performing maintenance on hosts, that they select the ensure accessibility maintenance mode option, which of course means that before the host goes into maintenance mode, it's going to recalibrate the objects such that they are compliant with their resiliency policy. So there's never any scenario where you're missing your n+1 resiliency when you're putting a host in maintenance mode.
All right. So I think very smart decisions, of course. Justifications. So these all link back beautifully, not surprisingly, to our requirements, which is we need to be able to tolerate failures and perform day 2 operations. So our requirement 1 and requirement 3 is to have resiliency during upgrades. So operations reserve and host rebuild reserve help ensure that our RAID 5 enhanced durability has sufficient capacity and fault domains, meaning nodes, to be able to protect the data with RAID 5. So pretty obvious one. It's pretty much a dependency of our requirements. So not really much of a choice here. Pretty obvious one.
Yep. And I think we already alluded to some of this information here as well. Like enabling host rebuild reserve means that there's going to be sufficient capacity reserved for a host to be rebuilt in the event that it's failed. And this is, we've been talking about how important it is to have that self-healing capability. So that that's what this is going to enable, to make sure that there's storage available for that to happen without anybody doing anything. The n+1 protection policy is going to be maintained. And then finally, again, I mentioned this on the previous slide, ensure accessibility means that we're going to perform the replication and data synchronization operations before the host goes into maintenance mode, such that there is never a point where we're missing that n+1 resiliency.
Absolutely. So it also, as it says here, helps ensure durability of change data during maintenance mode. So while you are writing new data during maintenance mode, this is where that enhanced durability, really is a step up from OSA for sure. So resiliency during upgrades is what we're certainly focusing on with these decisions.
Yeah, and this goes back to the using a larger number of smaller nodes where possible, because when you're putting a host into maintenance mode, if you are ensuring accessibility, if you've got a really large host, then it's going to take a lot longer to get that host into maintenance mode because it's got to synchronize all of that data.
Absolutely, especially in the case of a full data evacuation. If you have a 20, 30, 40 terabyte node, that's a lot of data to move. So ensure accessibility obviously reduces the overhead and only moves what's absolutely required. But yeah, a full data migration of a very scaled up node is a big task. So host rebuild reserve, it allows for maintenance operations to occur. It means you've got enough space there. So no point choosing ensure accessibility or having enhanced durability capabilities of RAID 5 if you have no capacity for the system to actually perform that function. So this is coming back to advertised features versus reality. And the reality is you need to design to be able to take a benefit of these advertised capabilities. You can't just assume that because you're running vSAN that you get everything on the sticker or on the box. You have to design to support all of these capabilities. And the last point is, if we didn't have operations reserve and host rebuild reserve and ensure accessibility, we simply wouldn't meet the requirements in this case. And our requirements, I would say, in this example, are not terribly strict. So, we simply wouldn't meet them any other way. So it's a bit of a no-brainer. I think any production environment, I think these are really good decisions to make.
Sure.
So implications. So I think implication number 2 is what you were alluding to earlier, which it does require some space to use these features.
Yeah, that's right.
So really we're talking about an overhead of around 13%, 12.5% for an 8-node cluster. But if you have, say, a 16-node cluster, this overhead becomes fairly insignificant, is in the single-digit percentage range, around 7%.
Yeah, we're continually seeing the rationale for using or for having a preference towards a larger number of smaller nodes in our clusters rather than a small 3-node cluster with very large nodes.
Absolutely. I think there's so many benefits to having more nodes. Your rebuild can occur faster, even in the event of a failure. You've got more network bandwidth available. You've got less potential noisy neighbor issues and contention. So there's so many reasons to scale out. So we'll definitely cover that in future decisions. I think some of the things to consider is, if you enter maintenance mode and ensure accessibility, entering maintenance mode does take a little bit longer. In some cases, it might be a couple of minutes. In some cases, it might be 10, 20 minutes. But it does take a little longer. But considering we're a 24/7 operation and we need to ensure that the data's got resiliency, it's business critical, having a slightly longer period of time for that operation, given that you can perform it during business hours, because that's any time is business hours effectively, I think that's a very good decision to make.
Yeah, but of course, we have to keep in mind, as we've mentioned there at number 4, there is that back-end storage performance requirement. So we have to make sure we've sized our nodes such that we can enter maintenance mode and perform those movements of those objects to ensure accessibility without impacting the performance of the applications that are living on vSAN.
Indeed. So again, we've made some very good decisions. We think they're well justified.
If you do say so yourself.
Yeah, absolutely. But certainly, we were obviously putting in a lot of reasons for it, and the operations team for Acme would understand and have in their procedures that they expect these tasks to take a certain amount of time because they're ensuring accessibility and resiliency for the environment.
Yep.
So the last one is, actually this is a duplicate, but it does give you a great example that the overhead on a 3-node cluster for these settings for host rebuild reserve would be 33%. So that's a pretty large number. But again, if you scale out, that drops to like 12.5%. So 3-node cluster, still important. If all you can afford is 3 nodes and that's your production environment, you still want to be able to rebuild. So probably worth capacity managing and sizing to take that into account.
Yeah. Although these days you can buy some pretty small nodes for quite a small amount of money. Like you can, I forget what it's called, but it's Supermicro. That's right. Supermicro have it's almost an Intel NUC size node. So if you really have a low budget, then the smallest node you can buy that will support vSAN is still pretty small.
Yeah, absolutely. So certainly I think 4 is a really good minimum, sort of a soft minimum, but then your resilience overhead is 25% instead of 33%, so you get a bit of efficiency back. And you can tolerate the failure and self-heal.
Actually, and if I'm honest, I'm not sure if I remember whether that NUC-sized Supermicro is actually a SAN-ready node. I think that potentially only supports OSA. So yeah, I'd have to find what the smallest SAN-ready node is.
Yeah, for sure. So yeah, looking up the HCL for vSAN ready nodes from your favorite vendor is definitely a good way to consider your decisions. So related decisions, again, we've talked about OSA and ESA a lot. That was our first decision. Failures to tolerate was our second decision. And our next decision coming up in the next episode will be the vSAN ready node choice. So this is where we go through the HCL and we work out what's the right node based on our assumed workload and our other requirements. So stay tuned for that. And as you can see, coming soon, vSAN ready node choice, vSAN cluster size, and then the VMware virtual distributed switch configuration to support ESA. So that is on the next episode. So please subscribe to the channel. Thank you, James, for joining us and sharing all of your knowledge as a HCI master specialist on vSAN, as I understand.
Thanks for mentioning that, Josh. Thanks for inviting me.
Thanks very much. Thanks for joining us, everyone.